Welcome to the student course Artificial Intelligence and Big Data. Now we are going to dive into LABLect3 hands-on exercise. Previous section was about NumPy introduction hands-on exercise. Now we are going to touch NumPy indexing and selection. Before diving into a practical part, I would like to explain a little bit about indexing and matrix. Based on the values you see in this matrix, how should the shape look? Can you please pause the video and tell me if this is one image including 3 by 3 matrix when we do NumPy array? So can you tell me this is related to which cell? Is here, here, or here, or here? So you should make a definition. Do you think that mostly we draw like this when we do the coordinated system? That means this is the 0, row 1 or 2, and this is the 0, 1, 2. Is it right? Then this is the indexing. Can you please pause the video and tell me and draw this one? So then this value, okay, after pausing. So if this is the coordinate system, this is the 100, right? And then this is indexing 0, row is a 0, and column is a 0. So row is a 0, this is the 0. So then this is the 150, like that, right? And this is 200. Is it true? No, this is wrong. This is totally wrong. So this is totally wrong. So what is the right? I just did this one to let you more pay attention. So the right one is when we draw the matrix like 3 by 3, the coordinate center of coordinate is here, not there. So the right answer is this one. So if 2D matrix, here is a 0, 0. So this cell then this row is a row 0, this is the row 1, and this is row 2. This is the column 0, column 1 when we are doing indexing, and this is column 2. So then here, same. This is the, let's do same color. So here column 0, column 1, and column 2. And here row 0, this is row 1, and this is row 2. So 200 will be here, which is row 1 and column 1. This is one point which you should understand. Top left is a 0 pixel. And another meaning here I would like to mention, when we are saying 0 means in a grayscale digital images, the pixel range value range from 0 to 255. So 0 represents complete black, and 255 represent completely white. Value between 0 and 255 represent various shade of gray. The closer value is to 0, darker. So this is less than this, should be here darker. And the value closer to 250 means this one is a lighter pixel, because close to the 250, which is completely white. This scale is used to define the brightness intensity of each pixel in a black and white image. So this is black because this is the 100, this is 250. So 200 more black than this one. So this is the 1 pixel. So this is not 4 pixels, this is 1 pixel. To more detailed one, I made like that because this means still light, not very black. If 0, you cannot see this line. Totally black if close to the 0. So there is one question now. What will be outcome after executing this code? So this is our matrix. We create a NumPy array representing a simple image. Then select the first and second rows from the image. So this is the first row and second row from the image because this was the row. This is the column. And here is a coordinate system is like that. You should understand. So when we want to select the, this one, because remember, when we say 0 to slicing 2 means not including 2. You remember in the previous hands-on exercise. So this is the one, means 0 and 1 row. So 0 and 1 row. So this select first and second rows from the image. And so this is select 1 and row from the image. So this is the here saying select only top left part means 2 pixel top left because 2 by 2 is here. So if you want to select this one, you should select also from 0 to 0 because this is the row, this is the row, this is the column. So 0 until 1 because 2 not included. So 0, 1. So that means this one and this one. So 2 by 2 pixel from top left part already selected. Then you can assign 0. So this is indexing and selection. Simply, I am teaching this one to show the basic concept, then go inside the hands-on practice. So we said assign 0. So this value should be 0. So after assign, the result is this. So these 2 by 2 value change. So this is the concept of indexing and selection. We will use many operations, but in the indexing and selection, we will learn how play with matrix, how select a specific cell from the matrix and change, add, remove. So this is the basic concept of the, indexing and selection. So I prepared this one to let you understand the basic concept. Now let's dive in hands-on practice. Simply Colab. You will start with new notebook. And as you may remember, we will do by titling NumPy indexing and selection. So in this lecture, we learn how to select elements or groups of elements from a NumPy array. Before we start, I must say that this hands-on exercise related, data analyzing and visualization. So let's jump right into our lesson by creating a sample array. So how we create sample array? Simply import. We need to NumPy as a NP. As usual, we'll start by importing NumPy as an NP. This NP we already mentioned. This is the alliance. This is the common conversion, and we'll stick with it through all the course. Here we're using arrange function. So to create a sample array that goes from 0 to 10. How you can do you remember? We are going to make an array from values 11 value, including 0, 1, 2, 3, 4, 5. Do you remember? Yes, we make an array numpy dot. So and by arrange, when we say 0 to will be created our array. This will be created in the memory. If we make a to print it, then we will see the result. So let's do bracket indexing and selection. So bracket indexing and selection. We will learn how to select individual element or slides from this array. It is similar to how we access elements in Python list. Remember that Python list, it is similar. To get value at a specific index, just use a square bracket. For instance, if we want to we want some value at index 8. Remember, this is index 0, 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So we want this value, right? Then how we can get it? Really, this is a similar list. So easily we can use array by a square bracket indexing 8. So we will easily get the value, right? So this is the 8, exactly this one. To get value within a specific range, you can use a slice notation. For example, we are going to make a slice like this. For example, from 1 to 5, we are going to cut like cake from that array, from indexing 0, then to 5, 0, 1, 2, 3, 4, 5. When I am going slicing from 1 to 5, what would be result? This is the 0, 1, 2, 5, which it will not include here. When I am saying 5, as you remember, a slice will be one number less. So when I am saying array 1 slice 5, this will be cut from here, yes, until here. So this is the result exactly. You can also get range from let's do here from 0 to 5. We could say 0 slicing to 5. Including 0, as well as we could remove this one. This result would be same. We can here, let's do broadcasting. So there is one concept which is broadcasting. In the broadcasting means we would like to set multiple value at once, add to whole array. For instance, if we put array when we do a slicing, we could say broadcasting assign this one to whole that specific part. Here we say a slicing from 0, 1 2, 3, 4. When we say 5 means until here. So we will assign a value 100. This will be changed 100 and the other value will be remain, not change. But here 100, 100, 100, 100, 100. This is the result. Then we can show that one. Yes, exactly. Let's reset array back to its original state with value from 0 to 10. This will be help us in understanding oncoming concept. So how we can, I already assigned this one to here. How I can bring back to 0, 1, 2? Can you tell me? Please pause the video. Okay, so simply we could do like this: array numpy arrange simply 0 to 11. Then when I show the array as a print, the value come to here, to original value. So now let's important notes on a slice now. Let's take a closer look at a slice in NumPy. When you are slice an array, you are not actually creating a new array. Rather, you are creating a view of original array. Any modification on a slice will affect the original array. Here we create a slice from array by selecting elements from index 0 to 5 up to but not including 6. We need to do like this: a slice of array, then we need to array from, for instance, 0 slicing to 6, means including until 5. So through this we create a slice from array by selecting element, right? And if we simply put it to see the result, copy and paste, so you will see result by 5. 6 element of array already shows. Now we are going to change all value in this slide to 99. Now when we modify this slice, it will be also modify the original array. This is the point. So if simply we use it, this one, if we use comma, then 99. So can you guess what would be result? Only we are focusing to the slice. If we show the slice, we will see. Let's copy, paste. You will see one array 90, 90, 90, 6 elements. So the original array means original array already slice here and put the value. So all value change to that one for the slice one. But see, if we want to see, this is for a slice one. A slice means we magnify 6 elements. But if you want to see the whole array, what would be the result? Can you imagine? Can you tell me if I want to see whole array, what would be the result? Can you tell me? Please pause. Yes, it will be shows array, because full array was this one. Here I just ask for show me a slice one. Only show same array here. But actually mainly full array including another element. So the result would be showing me array 90, 90, 96 element and 6 element, and then start from here 6, 7, 8, 9, 10. See? Exactly. So same array. So the point is, when we are doing a slicing, we apply to the main array. But when we print a slice, only shows that portion of array. But actually in the memory array already including this data. So change also reflect in the original array. This is because a slice is not a copy, but a view of original data. This is the point. A slice is not a copy, but a view of original data. So if you want to prevent this and make sure that change in your slice do not affect to the original arrays, sometimes you don't want to change original array, then you need to make an explicit copy of array. Then how you can do? I don't want touch to main array. Then what should I do? Because here when I apply like this, it will be affected to the array. Array will be changed. But sometimes I want to not change the original array. Can you tell me how can I do that? So then answer, please pause video. The answer is we need to use copy function. So array copy, then array copy, then we will copy that array to some array name is copy, right? What is the array? Because already array change. So if I copy, it will be go to memory. I want to see what happened. Then please show me array copy result. It will be shows same as this because already this is the array. I copy it. So exactly this will be shown exactly. So if we display copy array, we can confirm that it is identical to the original, but now independent of that one. So now is independent. We can do any procedure and operation here without any problem. Okay, now let's dive into indexing a 2D array. So indexing a 2D array. So what is the meaning of 2D array? Is exactly matrix. So this is the matrix. So a matrix which is already the concept which we are going to move to the 2D array or matrix. Indexing a 2D array is a slightly different. The general format is like we need to do like this. Array, for example, underline 2D. So bracket, here is a row, as I explained before, and here is a column. So generally it looks like this one. So let's do some practice. So array 2D numpy array, then we need to use the tuple, so one more, and we need to make the element inside. If we want to make a 3 by 3, then you need to make a bracket, for instance 5, 10, 15, virgule, another bracket, 20, 25, 30, 35, for example 40, one more, 45. So this is we already create 2D. Let's show it. If I show, it will be like this. You remember is we already saw before. We are creating a sample of 3D matrix. Each inner list, this is the list inside, represent a row of the matrix. To access a particular row, just pass in row index. For example, we would like to show first row. First row means this one, right? First row value. I want to this one. So this is row 1, row 2, row 3. This is column 1, column 2, column 3. So simply, if you put like this, and bracket 1 will be shows this row, right? So the this is the this is the 0, this is 1. Indexing start from 0. So if it is the 0, it will be start from here. So when you say 1, this is 0, 1, 2. And another one, if you put, for example, this one means from row 1, this is row 0, row 1, and column 0, this is column 0. So then would be the result, of course, 20, right? And if I put like 1, so this is the 1, column 1, it will be 20, 25. And this is the 20. Now let's do 2D array slicing. For 2D array slicing, we can cut it down a specific 2 and 2 submatrix. For instance, row until 1 means 0 and 1. So, and then to maybe from 1 to the end. So means 1, column 1 to the end means 1, 2. So I want to please stop the video, slice this one. How you can write it? Please stop the video and tell me how you can slicing this one. Okay, after pausing the video, result is simple. You need to make, we are saying this is 2 and 1. Start from 0, row means 0 and 1. So here row means start from 0, not including 2, means row including 0 and 1. So this is row 0, this is 1, right? And this is saying column start from 1 to end is 2. So here column 1, 0, column 1 means column 1. So that means what? When we integrate these two, it will be result, it would be this one. Let's make it black. So this is the result. So we will see it's exactly 10, 15. We see the result. Now, to grab the entire bottom row, simply pass in the index for the last row. In this case, you could use, you want to just grab this one. So if you say 2 means consider row, if only one number means related to row. If I say only 2 means this is consider only row. So this will be 2. Row 2 will be this one, right? So another way to grab entire bottom row is by using a column slice. How? We could say another way is using 2 means entire row 2. Then we could say whole column. This return all column from third row. So the result would be same. So now let's go for another section, which is fancy indexing. Another way to play with the indexing is a fancy indexing, which allows you to select entire rows or columns in a specific order. First, we'll set up 100 multiply 100 matrix, means 10 to 10. Let's start 10 to 10. 10 rows and 10 matrix, and then put 0 using the 0 function. Remember 0 function. We are going to make a one matrix 10 by 10. Value is 0. Can you do it? Remember? Do you remember from the lecture Okay, please pause and do. I want one matrix, R element is 0. Okay, after pausing, let me show you 2D array numpy zeros. So because value is a tuple, so we use tuple 10 by 10. So the result would be, so I can see it. Yes, 0 by 0, 0, 0, 0, 10 by 10. We'll grab the length of array. How you can get the length of array? Do you remember if you want to grab length of array using which attribute? Yes, please tell me. Yes, shape attribute. Second element of shapes gives us the number of column. So to do so, I want to see the length of array. So this length of array, I put array 2D already defined, shape. Then to understand the meaning of bracket here, let's remove this one. Shape attribute return tuple. That means when we ask, okay, this array now is a 10 by 10. So when we use the only shape, return tuple. What does it mean? Means return, this is 10 by 10. When we using the shape value, the result would be 10 by 10. This is the tuple. This is the put here. We will see. And when I am using indexing, because tuple has a now index 0 and 1. So bracket in front of the shape, can you tell me how many number can get? Oh, sorry, this is not 10, is a 0. So this is index 0 and 1. So the number in front of the shape only can be 0 or 1 because tuple is only 2 index. So if you put 2, it will be error because tuple not 3. Why? Because it's 2 by 2. If the array was 3D, means 3, x, y, z, 10, 10, 10, then you can put a 2. Okay, let's see in the code. You will understand better. So if I just put this one, and if I just try to see the result, you will see one tuple result because the result of shape is a tuple. Shows the dimension 10 by 10. See, 10 by 10. If array was a 3D, array 3D, you will see 10 column 10, a virgule and 10. But is a 2D, only you see. So because tuple has as index 0 and 1, you can only use 0 will be shows this one, 10, see? And you can use only 1, the second index. If you put 2, because it's not 3D, sorry, 2 or 3 after 2, error. Will be error. Tuple index out of range, because range is only 2. And even if you put 3, again, same error. So only you can consider between 0 or, okay. Now let's do one loop to select and add something. We are going to use indexing and selection. Can you please tell me, pause the video, how can I change the value of this matrix? I want to put first row is a 0 and two row I want to put 1 sorry, so this I want to put 0 0 0 0 and the second one 1 1 1 1 1 1 1, then 2 2 2 2 2 2 3 3 3 3 3 4 4 4 4 4 5 5 5 until 9 9 9 9. How can I do? Please pause the video and do it. Okay, simply I can use one for loop for I in range, because length already defined, array length, right? And then colon. So then we need to change in our 2D array. So now we are going to change row. I will put 1, first part means I, then simply I. What would be happen? Start from, see here, 0 put 0, means 0 column put 0. Then this is change 1, means 1 put value 1. So let's do, and let's check the result. See, 0 0 0 1 1 1. Okay, now let's talk about fancy indexing, because this section, it is about fancy indexing. Using fancy indexing, we can select multiple rows at once. Here, let's see, when I'm saying array 2D, right, do one matrix 2 4 6 8. That means I want to select only rows 2, rows 4, 6, and 8. Remove other thing. Notice that when I am doing this fancy indexing, this will allow us to select rows in any order. We can, let's first try this one. So see, I choose like 2, 4. Now I can try like this. For instance, like 6, 4, 2, and 7. This would be choose column first 6, 4, 2. Okay, let's do another thing, which is selection with comparison operation. Selection with comparison operators, right? Let's explore how we can use comparison operator to select a specific element from an array. Okay, let's create an array with a value ranging from 1 to 10. You remember, right? Let's create one array. Do you remember how? Yes. Simply NumPy arrange. We need to create from 1 to 10. Then we use from 10 number, right? Then we want to see. So we have one array. We can apply comparison operators directly to the array. For instance, array is bigger than 4. What would be? This would be shows that each value, will return a Boolean array where each element is true if the corresponding element in array is greater than 4, and the false otherwise. Because the first 3 elements are less than 4, this one and this one here, so we will see the array would be false, 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 false. And the first 4 elements of array, this is the false, and the others, it would be true. So let's do it like this to show it. Pulse array, put here, and then I want to see, you will see array false, 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 because less than 4, and then true, 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 true. So it should be yes. Here showing Boolean array, showing which value is original array or greater than 4. We can use this Boolean array to filter the original array. So to do so, when we use array, we can use filtering when I am doing like that, this will be returned only element where the Boolean array is true. For example, value greater than 4. So you will see the only shows. So through this we can do filtering. A simpler way to filter value is to apply the comparison directly. How? So you don't need put in this one in the Boolean. Exactly, you can put this one, bring to here. Like array bigger than 2. So this is bigger than 2 means showing from here to here. Remove this one. See? Showing only here. So we'll return all elements in the array that are greater than 2. This is simpler than combining a Boolean array with the original one, as we mentioned above. We can also use a variable for comparison. How? For example, you define one variable like x, and then array bigger than x. So this would be the same result. So instead of doing this one, you can do this. Would be same result. Yes. So here we store the value 2 in x and then filter array for values greater than x. Okay. So as a recap, let's wraps up our lecture on NumPy indexing and selection. We've covered how to access multiple arrays, work on a slice, perform selection based on condition. So as you can see here, what we did, indexing and selection, through the indexing selection, we can select a specific part. Broadcasting means send some value to whole, and then we can play like 2D matrix and then do slicing through the 2D matrix. If you want to cut some specific part, you can use through the slicing. Fancy array, we can a specific value to whole, a value apply and select a specific section of the array, and then use comparison operators through this way, put in some Boolean or directly filter Boolean, and instead of that we can use it directly inside bracket or assign through some variable. So great job, and I'll see you in the next lecture, which is NumPy operation. Okay, hello again. In this part, we are going to explore some functional NumPy operation and do some hands-on exercise. Starting with arithmetic operations on arrays and ending with universal array function. These operations are key when you are performing computation across arrays. So let's jump right into it. So let's make the new Colab notebook. So our discussion is for this section would be NumPy operations in Python for data analyzing and visualization. First, let's start with arithmetic operation. So let's do like this, smaller. You can use not italic, then 4 star we need. arithmetic operations. First, let's see how we can perform basic arithmetic operations between arrays and between an array and a scalar. For this, we will start by importing NumPy and creating a simple array using arrange. Let's try to create an array containing value from 0 to 9. And then try to some basic arithmetic operation. And let's first create and then do it. So at the beginning, we need to import. Always when we start new notebook, we need to do NumPy importing. So NumPy installation one time, but for each notebook, we need to import as a NumPy alias. Then you may remember when we create, we need to use to create the number, we need to use the arrange. For number from 0 to 9, we need to put 0 to 10. You know why. Then we can have this one. And so now is the connecting. So connecting now is connection done. So if you do, you can see the array from 0 to 9. So let's add array plus array. For example, array plus array. What would be happen? Array plus array. Then, means this array add is an arithmetic operation. As expected, adding array to itself result in each element being doubled. Now let's try, multiplication where we multiply array by itself. First do adding and then try to do so that multiplication. So when do you do this one, you already 0 plus 0 means 0, 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6, 9 plus 9 is this one. So if you use this one, but not, we use the multiplication, the result would be 0 multiply 0, 0, 2 multiply 2, this 2 multiply 4, it would be 8. See? To itself, sorry, not this one. This multiply to itself, array multiply 0 by 0, 0, 1 to 1, 1, 2 multiply 2 is a 4, 3 multiply 3 is a 9, is like that. Then we can use similarly element in the array or using the other like subtract, like then this will be 0 minus 0, 1, 0, it will be 0, 0, then 0, 0, this is the clear, everything would be 0. So let's go for another part, which is division. And special cases. Now let's see what happened when we divided an array by itself. But beware, there is an interesting behavior when we do division by 0. So let's say array divided to here. So can you guess what would be happen? Here, this is the array. When you divided 0 to 0, 1 to 1 is okay, 2 by 2 is okay. But when you divide it by 0, this is the issue. You'll notice that NumPy doesn't, throw an error when we divide it by 0, but it returns none, N-A-N, not a number. For first element, since 0 divided by 0, 0 divided is undefined. However, for all other divisions, it results in 1, since a number divided by itself is 1. So 1 divided, see the result. So here saying this is the none. This is the not showing error. So let's see another scenario when we divide a scalar by an array. So remember that a scalar meaning, because array has a several value. A scalar means only one value. For example, when we do like 1 divided array. Array has a several value. A scalar means only one value. We call it a scalar. So when we do 1 divided array, we get warning. And what would be warning? In infinity, INF, for first element. Why? Because 1 divided 0, this happened because 1 divided by 0. It is mathematically infinitive. And NumPy capture, gracefully. So let's do it. You will see showing the warning divided by 0 encounter in division 1 divided array. So showing in infinity. So infinity, because we divided 1 divided 0. But here we 0 divided 0. We call it a none. So 0 divided 0 shows by none. Any number divided 0, infinity. So let's go for other section, which is exponentiation. Okay. Let's use 2, because with the 2 hash I make it smaller. So exponentiation, look at how we can use and try to raise each element of array to a power. For example, cubing each value in an array. How we can cube? Simply use array, then exponentiation. QP means 3 times, power 3. So simply we use a scalar. This 3 is a scalar. As you can see here, this is simply each element is raised to power of 3. Okay, let's go for universal array functions. Universal array functions. Let's explore some of NumPy universal array functions. This function allow you to apply common mathematical operation to arrays as a whole. Instead of element by element, we easily can use apply to whole. Okay, let's start by taking the square root of each value in array. So I want to square. So NumPy for each element, a square simply, then through array. Then every element would be a square. This is because using T. So already this return the square root of each element in array. If you have a negative number in your array, this function would return complex number. To show the complex number, usually Python shows by none. Let's quickly make one array. For example, array, we make it some number. This one, right? Then this is the we assign the value, and then we try to use same for this array. Will be shows the none for this one because it's negative. See, for this one shows none. For other, okay, the square root is okay, and this is also okay. So for none, for complex numbers when the value is negative. Okay, let's now compute exponential of each element. How we can do? we could say NumPy expansion for our array, for this main array. So then will be, this will be as expected, this compute e raised to power of each element in array. So e power of each element for the main array. Let's now go for more universal function. We can find a maximum value in array using universal function like NumPy max. NumPy max. Although we can also call this function directly on array itself as a method. But let's try this one first. And also we can use as a method like array max. This is also same result as a method of this object. Both is okay and works very well. Okay, now let's move on some trigonometric function like sin function, cos function, tan function. Here how you can apply sin function to every element. Simply NumPy sin to array. The sin function apply elements wise just like other universal function. Now finally let's take logarithm of each element in array using np.log. Remember, logarithm of 0 is unified, so this will be raised a warning. So np.log array. So this will be shows, because that logarithm is infinity, shows warning. Because log of 0 is undefined. The other value are computed as expected. Okay, that's a wrap up of this section. We've just learned how to perform various arithmetic operation and use universal function in NumPy. With these tools, you can now starting performing complex numerical calculation on your arrays. See you in the next lecture. And we will continue more advanced NumPy feature, which giving some exercise. So before we go to another lecture, just quickly recap NumPy operation, arithmetic operation like multiply, array, minus, division, and special cases. Escalator use escalator, sometimes exponentiation, sometimes use square root, and sometimes exponential, max, some diagonalic operations, and log file. Okay, thank you. Okay, now let's dive into last section of NumPy under data analyzing and visualization, AI and big data course. To recap what we learned, as well as cover basic NumPy, now it's time to put your skill to the test. We'll begin with some simpler task and work our way up to more advanced operation. Don't worry, I'll guide you through each step. The reason I put this part to do some exercise as a class activity. This is not assignment. You don't need to submit anything. Some sort of hands-on exercise inside class. Okay. Here you can see some question. I will scroll down this question, and you need to see this one and pause the video. Please do it by yourself. because this is virtual classes, is not face-to-face classes. I trust you. So you need to just do answer first, input NumPy. Please do NumPy import. You already know I want to do some exercise. Later on, you need to create an array of 10 0 and create array of 10 ones, create array of 10 5. The activity 5, create an array of integer from 0 to 50, sorry, 10 to 50. Question 6, through question 6, you need to create an array of all even integer from 10 to 50. Next activity, create a 3 by 3 matrix with value ranging from 0 to 8. And question 3 is a 3 by 3 identity matrix. Question 9, as an activity, use NumPy to generate a random number between 0 and 1. I believe when you are doing this exercise, you will get many things. Then you need to use, this will be used in the exam, so please practice very well. Use NumPy to generate an array of 25 random number, sampled from a standard normal distribution. Create following matrix. Can you create following matrix through the NumPy, a little bit advanced NumPy we already talked? And then you create an array of 20 linear space points between 0 and 1. So this is there for basic one. And now for NumPy indexing and selection. Run this cell below. Then this is considered for this one. And for 13, task 1, replicate output. Use math using code that print this one. Based on this, cell we already defined. Task 2, as a 14 activity, replicate output. So to answer this task, first you need to run this one, get the matrix, and then replicate the output, come to the task 2, some access to a specific value from the matrix math, and then replicate the output. We need the range of value. Through when you run, you will see the matrix, and we need to select this one. You need to write the code. Replicate output this one. You need to do so, as well as this one. And further array operation, get the sum of all value in math, get the standard deviation of the value in math, and get sum of all column in a math. These 20 class activity, 20 questions, please consider as a, for example, midterm exam. Before see the answer through the following section of this video, please pause it and try one by one solve these questions. And then after that, you play the video again. Please, I trust you, follow my instruction. That would be very helpful to do some exercise during the class. Okay. Let's start from here. This is the answer. I'm going to the class activity answer. So import NumPy as an MP. So simply, always, this is the first step, as I mentioned before, is to import NumPy library, Python library. Let's import it using the common alliance NP. So import NumPy as a NP, right? So we already import. You remember to make a 0 simply within one line. NP zeros, simply 10. You can create one array with a 0, 0, 0, 0. Array of 10, 1. So you easily use NP ones 10. You can use, so 10 of 5 is a tricky. You need to use escalator. Same, you use this one, right? And then multiply is arithmetic, 5. So you can create 5. Then create of integer of 10 to 15. So when you are using the many times, try to range of 10 numbers, 0, 1, 2, 3, 10. Starting, we would like to have from 10. So same thing, we use range, NP, arrange. So starting from 50, including, so we need to starting from 10, right? 2, if we want to 50, we need to put 51 inside parentheses, 51. Then simply we will have an array from 10, 11, 12, 13 by 50. See? Yes, 10 to 50. So if you want to even integer, so same code, simply we need to add just 2. That makes even integer. Just 10, 12, 14, 16 is like that. Then you need to value ranging from 0 to 8. So we need to make a 3 by 3 matrix. So when we want to create 3 by 3 matrix with a value ranging from 0 to 8, we use arrange function to get the value and then reshape the array into 3 by 3 matrix. So that means we need, so here ranging 0 to 8 means NumPy arrange 9. So that means we will have one array from 0, 1, 2, 3, 4, 5, 6, 8. But we want to make it 3 by 3 matrix. If we go for that one, that is only array in one array. But 3 by 3, we need to use reshape. Reshape 3 by 3. So if you remove this part, what would happen? You will see one D array, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? When you do it, reshape it, that one. So now you want to make matrix 4 by 4. Can you tell me how? Easily, because when you put 4 by 4, you should put 16 number, right? Because 4, then this will be the answer. And remember, the value of arrange should be multiply these rows and column. For instance, if you put 15, you will get the error. So remember this point. So create a 3 by 3 identity matrix. You know, identity matrix is a square matrix where diagonal elements are 1 and the rest is a 0. So let's create 3 by 3 identity matrix using what? Can you tell me? How can I use identity matrix? So some matrix 3 by 3 means 1, 1, 1 diagonal, other element 0. Yes, true, by I. NP I by 3. So this is the answer. Now let's use NumPy to generate a random number between 0 and 1. So do you remember how we make a random number? Yes, between 0 and 1. So let's generate, we need random, and to generate the random number between 0 and 1, we need to use, can you tell me? Random NP, random.run, the function return random value, sampled from uniform distribution over interval of 0 and 1. So to do so, we need to use what? The number 1. So easily np random rand. So number 1. So this is the. Now let's generate an array of 25 random number sampled of a standard normal deviation. This time sample from a standard normal distribution which has a mean of 0 and a standard deviation of 1. For that we use which code? So random np random same random, but because it's the normal distribution we will use rand, but we will use rand n, that is normal. How many? 25 simply. So see, we will see 25 value. Okay, so let's create following matrix. For this task, we'll create a matrix where the values go from 0.01 to 1 in steps of 0101, because 0101 plus 010 is 2, 0.02 plus 0.01 will be, so 0.01 will be added to each one. So how we can use it? Can you tell me? Yes, we always use the arrange. We'll use the arrange function. Then we need to divide that value by, yes, by what? By 100. So let's do it. So simply np arrange. So we need here is 100p, so we will use from 1 to 101. This is the array. As remember, we need to reshape it. Reshape. So reshape it, matrix 10 by 10. And then we need to divide the value to 100, because this is all is divided 100. So we need to divide it 100. Let's run it. Yes, exactly, we get same value. So remember, in the exam you will see many examples. If you don't practice, you will not able to pass the class. So I am giving you a similar question, a little bit harder or easier. You should well prepare. So now let's create an array of 20 linearly spaced points between 0 and 1. For this one, do you remember what we need to use? Linearly spaced. Yes, we already practiced. np len spaces space. Then from 0 to 1, so 0 to 1, we need to array of 20, right? So 20, very easy. So you will see from 0 and to 1, you may remember I draw to 0 to 1 divided 20 section. So it will be same as this. Okay, let's, you did great job until now. So now let's move on NumPy indexing and selection. In this section, you will work on, work with the matrix and practice selecting and slicing data from array. Okay, let's use matrix defined below and solve task step by step. So let's create this matrix. So you can see 1, 2, 3, 4 is 5 element and 5 by 5. So if we replicate following output, how we can use for following output? So that produce this, how you can do it? Very easy. So here means they cut it down from here. So if you see here, from here, it will be like this. You need to cut from here, right? Then simply you remember when you are cut from here means column is from rows 0, 1, here is 2, 2, 3, 4, 2 by the end. So you need to do math 2 by the end. And then from here, column start from unit to 12, right? 1 to end. Column, this is 0, column 1, 2, 3 by end, 1 to end. So 1 to end. So very simple. See, the answer same. So replicate this output. Some specific value. You want to this value, 20. So this 20, it is rows 1, 0, 1, 2, 3. So rows is 3, column is 0, 1, 2, 3, 4. So 3, 4. So easily you can create this one. Math 3, 4 will be 20 selected. So you need to replicate this output 2, 7, 12. So here 2, 7, 12. So 2, 7, 12 means rows means 0, 1, 2 means from starting to 3. When you say 3 means 0, rows, zeros, rows 1, rows 2, 3. So easily you could say math until 3, and then for 12, 7, 12 means only you need this row. This row is a column, this column. Column is column 1. So you could say until 1 to 2, because when you say 2, not including 2. Then this is 1, 2, 2. Please pay attention. You cannot say, okay, a column is 1, you don't need this one. If you remove this one, this will be shows like in one rows. See, if you remove, this is the 1 rows. So this is very important. You attention to this point. Okay. Now replicate this output. In this task, we want to, grab the entire last row of the matrix. This is last row. You want to do last row. So last row is, this is 0, row 1, row 2, row, so this is row 4. But you want to entire, so row 4 and entire column. So very simple. You will use math, row 4, entire. So this exactly same as last row of this matrix. So now go to question 17. Replicate this one. To this one, for the final section task, for this guy, let's grab the last 2 rows of the matrix. So last 2 rows, these 2 rows means rows starting from 3 to including 4. So you need to put 5. So rows from 3 to 5 and whole column. So here, so math from 3 to 5 and whole column. So this one. Okay, let's wrap up our class activity, NumPy class activity, with a few more operations. So get sum of all value in math. means you sum all of this value. Very simple. Can you tell me? Yes. Math, sum, that's all. This is the sum of value. You want to standard deviation values in math. To find out the standard deviation of the value in the matrix using what? Simply a standard, abbreviation STD. Math STD. Then you can calculate a standard deviation. So get sum of all column. So you know math, sum, this is until here. But column, we will calculate sum of all column in the matrix. For this, we pass, we need to access 0 argument to the sum function. So access 0, you can do sum of all column through this one. You will see, for example, this one, 1, 6, 11, this is 21, 38, 37, 38, 48, 49, 55. So the array will be shows at first element 55. And then some of this, some of that. See? 55. Yeah, fantastic work. You successfully completed the NumPy exercise, hands-on exercise, covering everything from basic array creation on indexing, selection, advanced operation through this exercise, right? Making sure to practice this concept, practice and practice, as they form foundation of more complex data science workflow. So see you on the next section, which we will touch pandas. Okay, please try find more exercise practice, because you need to attention to the assignment 1. You need to be professional. You need to memorize the code. Okay, thank you very much for your attention.